So I'm going to go over how soils form and why they're different in different places. And then take that background knowledge and apply it to your homeland and the different types of soils that occur. And we'll go through a document that was published by a researcher from the Netherlands about 19 years ago, describing in detail the qualities of the soils and analyzing them and categorizing them into 6 different main soil types. So that's the plan, and we'll just go through this. Of course, we'll ask questions if something goes by too fast or not in enough detail, and off we go, all right? Let's see if I can, there we go. That and that. Okay, so there's what you should come away with, that you've got a soil starts from what's called a parent material. And that is acted on according to a lot of different environmental stuff, the processes that are acting on that parent material. What is the parent material? Because there's a bunch of different ones, and a lot of other stuff which we'll go over. So these are the soil forming factors, soil forming processes, and then a quick look at Curacao soil. Then for review, for reading, for more depth, pretty pictures, the Global Soil Biodiversity Atlas pages 10 to 25 will go over these same topics except for Curacao, of course. And then there's this document called The Semi-Arid Environment of Curacao, a Geochemical Analysis by this fellow named De Vries. That also, you'll have access to that, and we'll walk through some of the main features of that, and then maybe go through the whole paper bit by bit so that you have a better understanding of this paper. It's a bit technical, but we're not going to dig into exactly what the most highly technical things, mainly just the background and the results and the value of those results. So soils, it's a complex thing. It's one of the most complicated little environments we can know, and it's very difficult to know very much in detail. So we have to think of it in some simplifications. So the parts, we've got the parent material, whatever it is that this soil formed from. In your case, it's going to be, in most places, a bedrock material. It may also be sediment from erosion of other parent materials and transport into valleys. So then there is organic matter, and this is always in the upper layers of the soil on the surface, and then as deep as plant roots go, that is where the organic matter is. And then you've got water in the soil, minerals, the components of the sand and silt and clay. And then there's a soil atmosphere, or soil gases. So it's linked to the atmosphere that we're breathing, but it will be different because it's in soil and lots of things are going on down there that aren't so much going on up in the above ground. And then there's life. And of course, that's what's doing a lot of the decomposing and is modifying, as we've gone through, is modifying that physical environment of the soil and mixing it, moving it around, making holes in it. So we talk about soils as having layers or horizons as the terminology used in soil science. So there's these are given letter names. So we got O, A, B, C, and there are different namings of these layers, but the primary qualities of them are always the same. So you got your organic materials, which are concentrated near the surface. There might be an O layer, like if like you're in a forest and there's a lot of leaf material on the ground, that's the O layer. And then you have the A, the topsoil, B, subsoil, C, weathered or decomposed rock. So, and then the solid bedrock. So um, the A, going back to that, is what's called the eluviated layer. Now, this word simply means that the process of water moving material out of the soil vertically downwards is maximal in the A level. So the A horizon is defined by having been modified by the action of water moving materials down through the A and then depositing them into the B level. And so a B horizon, the subsoil commonly called, is where those moved materials go. So this can be a lot of different things. Even clay particles can be washed out, dissolved out of the A level, the uppermost levels of the soil, and then deposited deeper in the soil, and that makes a B horizon. So you can start with a completely mixed up pile of sediment. So this is like where Chris and I live. This happened many thousands of years ago. A lot of sediment was deposited here, and then the rain and the weather started to act on it and separated that mixed stuff into an A layer and a B layer. Now, where you are, it's a little different. There may have never been a stage where there wasn't a somewhat of an A layer and a B under it, but the processes are the same. Okay. Now, the weathered bedrock. Weathered means it's been chemically or physically modified.
I've got a question, Sam.
Yeah.
Because I can't understand how it could be that you have an A and a B level together, and then at a certain point it started raining. It looks like it was never raining over there, and then at a certain point it started to rain. So how the A and the B level were together, and then at a certain point by the weather. You don't understand me?
How, so like,
They got separated.
yeah, how did A and B become different?
Yes.
Okay.
So yeah, how did A and B become actually separate at all?
And they were first together.
If they started together, then how did they separate into an A and a B layer?
Okay. So let's imagine that the A, that what if you dig a pit in the soil, say a half a meter deep, if you can. It depends, it may not be that deep, but suppose you can dig a half a meter down, and you will see some different colors of soil as you do this. That's where you're beginning to detect the difference between an A and a B. You may see, you may feel a different quality of the soil, physically different between A and B. But again, that's after they have become different. So this example I was giving, where you can start with a, let's say, a glacier or a flood or something deposits a big layer of material on the land, and now it starts to go through a process of soil development. Or it's rocks that are crumbling in the weather, and becoming soil. So what happens that makes an A horizon different? Okay, it's a subtraction process. Materials are subtracted from the uppermost level because rainfall working and water going down through the soil dissolves out some materials, and then when they reach deeper into the soil environment there is different, and the material is no longer able to remain dissolved in the water. So it deposits there. So this is a very slow process. It can take thousands of years for this to reach any detectable differences. So, and what is normally happening, let's say in a situation where soil is developing on a bedrock, is you start at the, let's say you would have to imagine that long time ago, there was more bedrock there. So bedrock level was right at the surface. But then over the thousands of years, the physical breaking down of the rock creates smaller and smaller particles. At the same time, the rainfall is dissolving materials out, and they may not have very far to go. But as the weathering process continues, even if the bedrock is now covered by a thin layer of soil, it still starts to crumble and crumble and crumble. It's chemically changing and physically changing. So if we're starting out with, say, here at the, imagine that the rock is up here, like where the topsoil is now. After many more years, the rock keeps getting lower and lower and lower as the material of the rock gets converted into soil. And then we have this, so if you dig the hole now, you'll reach a layer of which it may just be simply decomposed rock. It looks a little bit like rock, but you can still get through it with a shovel. But then below that, you find a place where you can't. It's solid, unmodified rock. So does that help, sir?
Yes. Another question though.
Okay.
If I have a part of my at my land that do have like a rocky part, and certain parts is not like that.
So you have some rock showing at the surface.
So
yeah,
knowing her site, it's hilly, and water flows down to that valley where water collects from the whole area, right? Like you're at the bottom.
Yeah, but
so at the bottom you have a different soil. It's very dark.
Yes.
At the top you have more rocky soil. So this would have eroded some of the topsoil from on top and washed it to the bottom. So that's why when I came to your farm, it's like, why aren't you growing down here? Because all your good soil is at the bottom.
May be true. So yeah, especially on a slope, those fine particles generated as the rock breaks apart, they will be washed downhill. So they'll be constantly getting removed, which is one of the processes of soil formation. In one place, things are going away by erosion. This is different than the A and B thing. This is, you can think of this as more sideways and downhill, as different from going straight down through the soil with the water moving down through the soil. So your hillside, the soil forming processes aren't fast enough to build soil on that hill. It's always getting washed down You know, with any heavy rain, some material comes down. Now, if it were more thoroughly covered with vegetation, the erosion rate would be less. But for now, that's one of the processes that has made your farm have rocky parts and a lower area with a deeper soil.
So I can.
Another question.
Yeah. So I can. So now I'm thinking. So the places where it is nice dark is then where you can say it's in a little valley because it has different part with that.
Sure.
So that means that's right in the twin.
Yeah. Cool.
Yeah.
Okay,
Yeah, we're good.
onwards. So the key point is that these layers are made mainly by how water has and dissolving action of water, and also the influence of the life in the soil, the plants and fungus, everything. They plants and organic matter does make some soil minerals, some of the rock particles dissolve. It has a chemical influence as well as a physical one of like roots going through things. And also, these layers can be mixed by animal activity. So a heavy, a large amount of animal activity would very much, it could even erase the difference. So there would not be an easily detectable A and B. It might be all mixed together, or the boundary between them could be very uneven, or we could say fuzzy boundaries. You would not have a sharp transition. It would be very gradual or irregular. So animal activity can modify all of this. Okay, so the soil forming factors. This is sort of, soil science 101. We go through these things. The parent material. So a factor is something that sort of defines it's the environmental context for the soil. What is it starting from? It could be starting from a sediment. So material that has eroded from one place and been deposited there. It could be weathered bedrock. And these are sometimes called residual soils. It's the residue of the bedrock. That's the weathered bedrock becomes soil. And organic matter is also a parent material. There are soils that are purely organic matter. You probably don't have them, but there are, what's called peat is a pure organic matter that is basically a kind of a soil. There are tropical peats, there are cold climate peats, but they almost all require a relatively humid area and slow decomposition under conditions of high humidity. So mostly we're talking about then sediments and weathered bedrock as the parent material. Topography, is it hilly? Is it flat? Is there erosion away from the spot where we're looking? Is there deposition of sediment onto the spot? So this is one. Hilltops will almost always have a different soil type than the slope of the hill, and the flat part at the bottom of the hill will almost always have a different soil type than the slopes or the tops. And then you have valleys where water has been carrying material and pushing sediment around. That creates a sediment type of parent material. And that's where you would see soils derived from sediment, from the deposition of eroded stuff, like that, the woman's hilly farm. Climate, of course, very important factor. And with water, how much rainfall there is, what temperature it is, and these affect weathering. And weathering, of course, is one of the processes. But the maximum rate of weathering is from high temperature, high humidity. And weathering under those conditions can extend meters down into the rock. I've seen road cuts in several countries, most recently Brazil. There was probably 3 or 4 meters of reddish purple soil-like material, and there was a big stone at the bottom of all of that. And the stone, you could see it was like an onion. There were layers of the stone that were breaking away from it. That was the last bit of stone. Everything else had been weathered to a crumbly red material. We would call that decomposed rock. Not quite yet soil. That would be the sea layer. So weathering is fast at high temperatures and fast when it's wet, and it's fastest when it's hot and wet. So there's been some interesting changes in the history of Curacao soils over the millions of years. Okay, another factor, soil life. What is there? What's in that environment? Many environments, if they're too dry, they will not have earthworms, but they would have ants and they would have termites. If they're extremely cold and wet, they might not have ants and termites. They might have earthworms, or maybe not. So there's a lot of variation what life is there. And of course, plants are part of soil life. So climate, temperature, all of that helps determine what plants can grow in that area and how much they grow. And that affects, first off, the organic matter, and second, by the chemical quality of the organic matter, it has an influence on the weathering process. And the last one is time. So time is very, very important because all of this stuff is relatively slow. Again, hundreds to thousands of years to have measurable change in soil from these natural processes. So you look at your island and how old is it, and is the soil all this old? Well, maybe so, but it's constantly being formed and somewhat constantly, I hope not constantly, being eroded away, but in small amounts, it's always, some is going away. It ends up in the sea. But time is important. As with more time, you get more of all of the processes can act. And it's because processes take time to do their work. That's why time is a factor. The other things, they are stuff that's there. Certainly, over the long term, climate can change from dry to wet, from wet to dry. But for now, that's the factors. Just a brief look at those. And the processes. So weathering, we've talked about this. It's physical or chemical. Physical is just breaking up. So in bedrock, we're talking about big pieces of rock becoming little pieces of rock, becoming smaller and smaller, and down to sand and silt. And chemical weathering is the modification of the minerals making up that rock. Rocks are made of minerals, and many types of minerals even per one rock. And some of those minerals will be modified greatly by exposure to air and water and organic matter from plants. Others, no, not very much. Everybody know what quartz is? It's this.
What is it, guys?
Got quartz around?
Quartz.
Yeah, in Colombia.
Yeah, it's a mineral. You want to describe it a little further?
Me? Them.
Yeah, it's Sam. Yes, you're sorry.
Okay. It's typically white or clear and often occurs as a vein, like a layer a streak in some other rock. But it's one of the main components of many of the volcanic rocks, although not so much in basalt, the dark kinds of rocks making up much of Curacao. However, it's also chemically almost identical to ordinary glass in windows. So it's very resistant to weathering. It is very stable, and it can last for a very, very long time. So when other minerals have all dissolved and been modified, the quartz may remain the same. Okay, leaching. This is the process where something gets dissolved out of the soil and deposited deeper in the soil. So you all know what leaching is. You do it when you make coffee or tea. You are leaching the good stuff out of those plant materials. So the same thing happens in soil. Rain falls on the soil and something can get dissolved out of that upper part of the soil. So that's the process that creates an A horizon and a B horizon, where materials are being dissolved away from the A and deposited in the B. And clay movement is one of these things. It seems strange, but clay, some kinds of clay will dissolve in water. Now, I would say don't try this at home. Well, you can. You can try this at home. You won't see anything happen because it's really slow and there's not very much, you know, the clay mineral, remember, these are tiny, tiny crystals. They can dissolve, but not very much. But given enough time and rainfall, the clays that dissolve will be transported from the A level to the B, or they will become the process of differentiating the A from the B. So when in most soils, the B layer is a higher clay content than the A, and this is why. Transformation of clays is another thing. There's many different types of clay, and they can be converted from one type to another type over long periods of time and under different conditions. And that goes back to the weather, to the climate. What are the climate conditions that favor one kind of clay over another? Okay, translocation, erosion and deposition. That's just almost impossible to talk about soils on a landscape that isn't flat without bringing up erosion and deposition. And even on flat ground, you can have erosion if there's intense rain or dust erosion. So there's wind and water movement of soil and depositing of soil from the wind and water in other places. And then finally, bioturbation, because there's always something alive moving soil particles. So it could be little animals, it could be big ones, it could be plant roots, even a tree falling over, getting uprooted, falling over in a windstorm, picks up soil with the tree roots and inverts the soil layer, exposes subsoil layers, and then soil development starts again as that tree rots away. What was on the bottom is now on the top. What was on the top is now on the bottom. So there's all kinds of bio disruption of soil and movement of soil. Okay. So water flow is a big important part of it because you've got what we call the precipitation, the water that's coming in, And then the water that's going out is the evapotranspiration. So transpiration is going by way of from the roots of the plants to the leaves. Evaporation is just drying off of the surface. So, you know, when you're mulching, you're trying to minimize the straight evaporation. You're trying to leave the plants as much water as possible for transpiration, because it's that water coming up through the roots and out through the leaves that makes the plant able to bring nutrients in and then to photosynthesize. That always costs some water to do photosynthesis. So precipitation and evapotranspiration. So this is, these depend on heat and light. The warmer it is, the more of both evapotranspiration. And then we talk about two things here sometimes. This is relevant to soils. Is actual evapotranspiration and potential evapotranspiration. So actual is what really is going back into the air. So whatever evaporation there is, whatever transpiration there is, that's the actual. Potential evapotranspiration is something we use to indicate how much more water could have evaporated or transpired if there was an unlimited supply of water to that place. So this becomes important because if the potential evapotranspiration is very high, greater than the amount of rainfall, then you have a dry environment, a dry climate. And this affects how soils develop. So I've deleted from this anything where we have a lot more rainfall than actual evapotranspiration, or a lot more rainfall than potential evapotranspiration, because that's not what you're living in. You're living in where it's either it's close to the actual evapotranspiration. So then when it rains, the water moves down into the soil and carries some material with it. So that's loss of clay from A and deposition in B. And then it may then come back up again. The water starts to be drawn back up through the soil and the plant roots as the topsoil dries out, as plants are using water and transpiring it back into the air. So this soil view you're looking at is something I might see if I dug a big hole near where I am now. And you can see across the center section, this lighter colored area. This is where clay has been deposited. And the darker area up here is reduced in clay and is increased in organic matter by the action of all of this plant roots. Okay, so this is a characteristic of grasslands in the higher latitudes. What you're looking at is more where precipitation can be less than actual evapotranspiration. Now, how can that be? Well, you have to supply some water, but where you would get net water movement upwards. You would get very little tendency of water to go down through the soil profile and into groundwater. You would have a lot of a tendency for water to move upwards through the soil and on salt-enriched soil, particularly if there's
Hey, Sam, we're having a little bit of a connection issue.
Pump a router or something, didn't we?
dropped him. Okay. All right, Sam, we're in our seats. Let's take it away. Sam? Oh, no. Oh, there we go.
There we go.
Great.
All right.
It's in the class.
Internet connection is unstable.
On your end?
That's what I'm getting. I don't know if it's my end or yours, but as long as it keeps going, I guess we're okay.
All right.
So, obviously, irrigation is a big concern in dry climates because of this tendency of water to move down, then up, pulling up the salts. You end up with a salt crust. That saltiness breaks up soil structure. Remember, that's one of the ways to get your jar tests to work really well is to put some salt in the water. It works out in the field too. It breaks down the aggregation of soil particles. So not good. So let's just do a little summary here of soil development processes. Things can be added, like organic matter or non-organic, you know, the other soil or sediment. And, or if you're using fertilizer, it's, you know, powdered up rocks, for example, are permitted. Losses from erosion. So erosion and deposition, you'll see up there at the top are kind of going sideways. And then you've got ladder or translocation, transformation. So that's the vertical aspect, leaching going down. And then it can be drawn back up. If the surface is drying or the roots are pulling water out, water can actually be sucked up in by the drying soil. Water has a natural tendency to go from wet to dry in soil. So that can happen up to a point. So that's one of the reasons that minerals and nutrients can be drawn back upwards, even if they've been going down. Okay, and then you've got that animal movement of soil. So here's a picture of at the bottom of a gigantic earthworm. This was a 2-meter long earthworm. And you can see that it has deposited some of the subsoil, the B or even C horizon, I'm not even sure which, from deep down. It has eaten some of that and defecated it at the surface on the gray upper soil layer. So you get transfers between horizons based on animal activity and on these water movement and erosion or movement in when it's dissolved in water. And then you can have structural changes of the materials. So that could be modification of clays or further weathering of breaking down the soil minerals of the rocks and stuff. Okay, and soil influences, the animals and stuff. So you've got, they can change the porosity of the soil, of course, by making their burrows and chambers. And these affect a bunch of different qualities of soil that are measured as things like bulk density or hydraulic conductivity. That is how well water moves in the soil. It can change the field capacity, so how much water the soil holds when it's fully wetted and gravity has been able to remove excess. And of course, it affects the drainage. Aggregation, we went through that pretty thoroughly. Crust formation is something when aggregation breaks down. And this can be even from heavy rainfall impact. Some aggregates are stable when they get wet, others are not. Patogenesis, that's what we've been going through today. All of these different things that animals in the soil do. And you've got removal of organic matter from the soil surface. You can have transport from one level of the soil to another vertically. And then litter and residue processing, of course, this is the big thing that they do. changing this particle size, decomposition rate, microbial activity, and all of these things we already spent a lot of time on, just putting it into this whole how do soils change. So now, in the Andes Mountains, whoops, we got some instability again.
Yeah, let me see.
No, I'm back.
I can cut out my video maybe.
All right.
All right, we'll just
All
cut
right.
out ours and maybe that'll help out.
Maybe so. Okay, so this is, so what you see here is in the center left of the photo, a bunch of rocks and stones here. And that's the original weathered material. So this is in the mountains. So there's, you got some broken up stones and sediment. And then on top of it is this yellow stuff. This is volcanic ash. Now the old soil surface would have been at the boundary of the gray and the yellow here. But there were a lot of deposits of ash. So there was a lot of eruptions. And so you don't see any evidence of soil development in the middle of this broad band of yellow. But then it stopped. So some years and years of eruptions, and then the ash deposit stopped long enough and soil development processes could start to make some changes. And here's a closer view of the same situation. So you've got plants up at the top contributing organic material and then the weak acids, like the stuff that's coming out in your tea or your coffee. That's a weak acid. That starts affecting the volcanic ash and starts moving materials down. And see this white line? That is probably a mineral deposit created by the motion of water down through this volcanic ash layer. The material here, pumice, is what's called it's like a fine volcanic glass. It's a very low in nutrients and is very sandy feeling. It doesn't hold water very well. So anyway, this is due to massive volcanic eruptions in Chile, dumping volcanic ash in Argentina. This is another example of soil development.
Question.
You got a question, Sam?
Sure.
Así es.
Where are we going?
One sec.
Maybe you can do it in English, but
Yeah, ask in English.
you want to ask it in English?
1 second, Sam.
You need a translation in there, huh?
Stay with me. There you go.
Pentamento.
So he's talked about in the first hour about different horizons in the soil, topsoil, and the organic matter on topsoil are generally the best and most available nutrients, best quality plants to grow in. And then there's a B horizon, which is more minerals and eroded soils that have kind of gone leached out of the tops. A horizon and gone to the B. So that's less conducive to plant growth, but there's a lot of minerals down here. So if you're going to plant into this volcanic ash, it would be the plant material, the soil life, the erosion, the chemical physical processes changing the ash and the depositions into a like topsoil.
Okay, are we ready?
Sorry, one more second, Sam.
Sure.
Yeah, I mean, you're not going to be able to get into the sublayers of like rock very easily. The formation of topsoil takes a long time, so if you want to get it done very fast, then placing materials on top that are closer to topsoil would be the fastest way. You know, applying compost or putting on biomass, you know, mulch layers, things like that, to start creating organic matter on the surface.
All right.
Okay, we gotta move on. The whole class can't really hear you, so.
Okay. Okay, good. So all right. So this is just, you know, it's kind of an extreme example of soil trying to happen. Here's another one. And in this case, it's a bedrock that this is exposed in where a road was built. So you can see the uppermost layer is very dark. That's rich in organic matter. And then you have broken up stones here. That's like would be the C. And somewhere up here, I don't know, A, B, whatever. But this is a cool grassland. And this is the bedrock exposed. But we can see a kind of a slice through the earth. And it's a very high nutrient rock. It's similar in composition.
So that's super dense rock with organic matter and created topsoil on top of it. A lot of that is from plant action in the short term,
Right.
and the long term would be from rain and humidity and temperature. So that top meter, whatever it may be, just growing plants on it created that over time, much faster than if
that's
you
what
went
your
on.
soil looks like.
Yeah. Yeah. So you could get that quickly, kind of what Fabina was asking about. If you wanted to get something plantable fast, you wouldn't want to hammer into that bedrock. That would be a waste of time and energy. You'd probably, if you were desperate to plant something as fast as possible, you'd be buying soil or buying compost, putting that on top and planting into that. And then the longer term strategy, the medium term over the next several years would be planting things that accumulate biomass, break down into topsoil. Kind of Roland's talked about his place several times where he's applied mulches, he's grown things and laid them on the ground. They break down. Now he has accumulated a few centimeters of soil, basically, just from a few years of doing, 3 years, Roland?
3 years.
3 years of putting down mulches and growing things. He's accumulated how many centimeters?
5 centimeters.
About 5 centimeters of topsoil. So, and that's, he's working at it, but he's not exhausted doing it either. That could be faster if he wanted to do it.
Okay. Yeah, I should mention that humans are one of the soil forming factors, a very important one in many places. Okay. So this one, that's another view of the same situation. And there you can see there's many small white fragments in this dark material that indicates presence of little stones. So it's not just purely organic matter, it's a combination of organic matter and minerals. And then there's a hole here, some animal has been living. But you can see this relatively sharp boundary between the bedrock and the overlying soil that has developed in this place. Okay, weathering. This is just a sort of a little picture tour. This is granite, a very hard rock, very resistant to weathering, but yet it is weathering.
North Coast by the sea.
Or North Coast.
North Coast, you see by the sea.
Oh, they see that on their north coast quite a bit.
Yeah, so pockets developing in rock as the the rain and the salt air and everything start breaking, making holes in the rock.
You see it on our roads also.
But that's something else.
Yeah, their roads are constantly turning into topsoil.
Right. Yeah. Vehicle action is one of the underappreciated soil forming factors.
Sam's got some interesting data and maps about the soil types of Curacao. We'll be able to look at that.
Yeah, that's coming up.
That are here pretty soon.
So these are some of the examples where there's stuff is growing just on bare rock and slowly eating it away. And another shattering, and this is like breaking up, physical weathering of rocks. Okay, and onwards. And then you can have deposition as well in some places, like carbonates, like limestone and the main ingredients can be dissolved by water, but then deposited also. So on the left is outdoors in the full air of a place in Thailand, and on the here is something from a cave where the water has dissolved the stone and now is redepositing that stone in a different form. And then here you've got another an area of granite. Very.
Question here, Sam.
Yeah.
Amina? Yeah. See, it was carbonate. So what? Could you describe carbonate a little bit more, Sam?
Okay, carbonates are things like calcium carbonate, which is calcium with a CO3 attached. So, sodium bicarbonate you use in the kitchen for baking soda or to neutralize acidity if you're having a problem in your stomach. And that's calcium carbonate is what limestone is made out of. All those corals are making solid calcium carbonate from the seawater. There's dissolved calcium carbonate in the seawater, and the corals bring it down to make a solid coral skeleton. And then as limestone, it can be dissolving again in the water from the rain. And there's magnesium carbonate, and there are other carbonates, but the calcium and magnesium are the most important. That's what you will find in the limestone rocks of the island.
So to use like
Another question.
So to use like the rock dust from the limestone is good for the plants then. That's
It can
Yes.
be. Yeah. Using those rock dusts can be an effective way to mineralize your soils or add nutrients. But going back to our lectures with Jim, talking about soil tests, you should be aware of what that's made of and what your soil has before you just start adding things to your soil.
where I live, you have like a layer of limestone. And underneath this, when you crack it, you find like this red dirt.
Mm-hmm.
And the soil is built up out of that, some parts of the land. So normally I find the rock dust inside the earth already, so I don't have to add it, but it's already there.
Yeah. I think something we'll see coming up is that there's a lot of minerals available here already. I mean, your soils have a lot in them already. There's other factors that might be limiting how useful your soils can be.
Okay.
pH, yes. pH would be one example. Lack of organic matter would be another. Lack of structure. And we'll get to there in just a few more slides. All right, Sam. Oh God.
It's free.
Please. Come on, Sam.
Make a move. Wake up.
There we go. All right, we got your back.
Okay. Whoops. Okay, I thought I'd. Yeah, so here we were. This is, okay, just a very resistant rock, and it's a very, very thin soil. And then here's some sandstone. showing, you know, the mineral streaks and erosion going on. Now, Curacao.
So,
This is what we've all been waiting for, right? Note that this map is not tilted to north at the top. It's a little bit of on a slant. So we got the major types of rocks showing the geological map. So limestone is in this white area around the edges. You're all familiar with that.
especially
Then the other most common one is these lava. This is the basalt or the lava formation. That's where all these little V's are here. Two sides, west side and east side. And there's a little bit here, but mostly it's this and this big part in the south and east. Then there's what they call the Midden Curacao Formation. In between them and something else called Knip Group. Not so much, but it's a bit of it around here. So this is the, you know, I guess you could probably, with a little bit of time, you could figure out where you are on this. You know, there's the city. Where is my farm? You know, is it on the V's? Is it on the whites? Is it on this Midden Curacao?
I would guess that most people are on the lava formation, and then a few are on the midden. Let's see.
no one is on the line. I'm on the line.
I mean, where would
Yeah.
I mean, Barber would be somewhere around here, I think. Barber.
There's the harbor.
The other side, here, of course, we are on that side. I'm on
Yeah,
that side.
this is Willemstad. I'm talking about trying to place Barber. So Barber would be somewhere around here.
Yes.
Right?
Oh, yeah, Daniel is, yeah.
Yes,
Yeah. I thought because we call him Baba.
No.
You see?
Because of his beard.
What about you two? Where would you guys be? Would you be on the lava, or would you be maybe out on the lava? Yeah. So most people are on a lava formation in general.
Okay, so everybody's found their farm, pretty much.
Let's see it. You said you're on. What were you on? In the middle. You're where are you? Yeah, there you go. Yeah. Cool.
So we've got a few people on the limestone.
Yep, a few on the limestone, a few on the knip, mostly on the lava though.
Okay, the Knip, which is like around this west end lava section.
Yeah.
Yeah. Okay. Yeah. Well, that's okay. That's good. So we have a majority on the lava formation, and that could be a good thing. We'll see. All right. So we've got yourself figured out where you are, and now you're going to look at what's some of the qualities of the soils in these different areas. So just to say, this is MC is Midden Curacao, then the Knip, and then lava, no, wait a minute, limestone north, limestone south, basalt west, basalt east, and then there's this other one called Sal, S-A-L, salinized, or salty. So yeah, if you're on we'll go backwards, you know, this basalt west is this part, basalt east is this part. Good, you knew that, right? So that's just separating. So this is showing the sand, silt, and clay. I think we can safely say that there's a lot of relatively high quantity of sand, relatively low clay, and then a good amount of silt. So these should be relatively easy to work with some exceptions. Silt loam, silty clay loam, some differences there. Right.
I think the LBV farm I just looked at be like a sandy loam, so something like one of these is kind of what I found. That was actually almost the exact percentages of sand silt clay that I found in some of my samples. So
Would be like the 50-47, like these guys right across here, the BEs.
pretty close to that, yeah.
Yeah. Okay. Do you think that that LBV farm is in the basalt region?
Oh yeah, for sure.
Definitely. Okay, good. Oh, we can relate it. So, and this gives you also the size range in case you were wondering what is the size range of sand, silt, and clay. So 2 millimeters is the top end of sand, and clay is anything that's from 0 up to 2 microns, so millions. All right, now this is measurements of pH, carbonate content, so this would be primarily calcium carbonate, and then organic carbon. ND means didn't work or not done. And so pH is measured in 3 different ways here. So most commonly we just measure it in water, but it does make a difference. So, but at any rate, it looks like most of the soils are what? Acid, alkaline, or neutral? Which one?
Alkaline.
Yeah, slightly alkaline. You know, anything above 7, there's several of those, especially in this column, almost everything. Change the measurement, doing it in a potassium chloride solution, the numbers go down a little bit. But there's no strongly acid soils in Curacao. You don't have to worry about that. But sometimes a little acidity is a good thing. I mean, if you're going to be adding crushed limestone, that would generally raise the pH. And plants sometimes on their roots and with their mycorrhizal fungi, they can microacidify right next to their roots, and that helps release some nutrients. So you might want to consider, as Chris was mentioning, look at your soil test before getting out there with the ground up limestone. It might not be helping.
Question?
Yeah.
How can easily measure the pH?
So we're getting some of those simple soil tests that Jim talked about, the ones that you do the test and it brings up a color. You just hold a card next to it. We're getting a couple of those, and we can start doing those on everyone's farms and start getting some ideas of what's going on in your farms. Okay.
Okay. All right. Carbonates, we're not going to worry about that too much. And then organic carbon, that kind of on the low side, but not too bad. So 2 to 3% of the soil mass is organic matter or organic carbon. So the actual organic matter content could be a little higher than that, because it's just counting the carbon atoms, not everything in the organic matter. Okay, so again, so this is a broad scale survey of the soils. And then chemical composition, so what kinds of minerals, nutrients are in there. So then the major elements, the most common ones, aluminum, calcium, iron, magnesium. In this case, they're clustering these soils into the 6 main groups. The sandy limestone, midden Curacao, arid, calcareous means high in calcium carbonate. So that would be something probably on a limestone. Basalt west, agriculture influenced, and basalt east. So they did an analysis of the soil samples they took, over 120 of them, and some of them they called agriculture influenced because the human impact of fertilization had so changed those soils, they came up as a soil classification of their own. So is that clear? Yeah. All right. So you can see that generally speaking, there's good amounts of iron, magnesium, calcium present, and then minor elements of some importance like chromium, manganese, nickel, phosphorus. You can see that the AI, this one, agriculture influence, is fairly high in phosphorus, indicating phosphorus fertilization was probably happening. And then there's a few others here like vanadium, zirconium, and titanium. I don't really know why anybody cares about those, but they measured them. They may be of some use in plant nutrition. Chromium is often an indicator of, that's a heavy metal. Don't necessarily want that in our food, but it does occur in the soil because of the nature of basaltic rocks. These things tend to be common. Also, using nickel tends to be higher in the basaltic areas, though not only. So on. Okay, so let's move along. So this is an overview. This is like a kind of a quick guide to the soil types. So here you have a description. Sandy limestone, orange, brown, sandy, easily leached, resistant minerals, lowest in the major elements of aluminum, iron, calcium, magnesium, and low trace elements. Then midden Curacao, yellow-brown, shallow, slightly weathered, a lot of gravel. So this is like where erosion has transported small stones into this central area of Curacao. Got a lot of potassium and plenty of other things like potassium, lithium, and zinc. And the arid calcareous soils, these tend to be sandy to silty texture. Some of them are saline. They may be very porous, so they're not going to hold water very well. And for some reason have a lot of titanium, but again, that's not an important plant nutrient. Basalt West, orange brown. Oh, there's a lot of orange brown going on here. Silty loam textures, so mostly related to the Basalt West formation. High levels of major elements and trace elements. So this can be good. Then, second, we've got agriculture influenced soil type. And I'm sorry, I don't really know where on the map these are. Relatively deep ag soils or gardens, alluvial soils, which means they were carried, the material was carried by water and deposited. And then there's a lot of calcium and other elements that were influenced by the use of fertilizers, manures and fertilizers. Maybe all.
Alluvial soils are at the most at the north side, just before the sea. So you have the north side, you have a rock formation just before behind the sea. So right, those are soils carried by rains every year.
It'd be where water slows down for a moment, and then the particles can drop, and then it goes on into the
So west of the airport, you have a lot of farms there. Some theater area, there is one very good example of this. On the other side of my farm, so
here we are again.
All that area is also.
So are you on soil like that? Or are you?
No, I'm this side of the rock.
Okay. Interesting. Just learning a little bit about where some of those agricultural influenced soils might be. That tend to be on the north coast, I guess you could say northeast, kind of. North coast. The whole north side. Gotcha. Interesting.
Okay, so that's where traditionally agriculture was done, I guess, huh? brown relatively deep. So yeah, where the best places are, that's where people probably started farming. Yeah. Okay, so I was just jumping to the next slide after that. Do you want to, anybody have more to say about these things?
Do you want to talk about basalt yeast real quick? We lost you for that one.
Basalt yeast, right. So this, what I found interesting is that even though it's the same kind of lava or same age of lava, they're different. The west lava is different from the east lava. They also, in this paper, did sampling of the bedrocks and ground those up and looked at the contents and saw some differences there. So anyway, this has got a relatively low potassium content in basalt yeast, although I'm not sure if that's agronomically significant, like if that's a problem. But then I went to the next one. Here we go. So the author in his comments about the soils said that you can probably do some alternative ways of solving agricultural problems while not creating any more environmental ones. So he said the BE, the basalt yeast, has a high potential as a natural fertilizer. He suggested mixing that with the MC or another phosphorus-rich limestone would make a mixed soil with better agricultural quality. So it's basically said the ideal soil of Curacao would be a combination of two, a BE and something else. But moving soil is pretty expensive.
So if you were to combine several of the soils, you would get an ideal soil. Or
as good as you could.
The big takeaway is that where most of you are farming, the soil is pretty decent already.
Yeah.
What it's lacking is probably organic matter, structure, and a little bit of life. That's what I.
Agricultural days came back.
Yeah.
They used to dig the dams because they're where you get all the deposits of greens, all the topsoils are washed and you on in the dams, and then they would dig those up when they do maintenance and then spread it back on the farmland.
So they already knew. That's awesome. So back in the day, the last several hundred years of farming, people would dig dams or make dams in the alluvial areas, collect the sediment and then spread that sediment onto their fields. So just by doing, probably trial and error over and over again, people found out exactly what to do, that this scientist is saying that pretty much the same thing. If you can find those deposits, spread it out onto your fields, they'll combine and create a pretty sweet soil.
Good. Yeah, the paper actually mentions these structures. There are many of these dam structures, and I think the guy didn't really know why they had been put there, but now we know.
Very cool.
Also mentions that there were some parts of the limestone are enriched in phosphorus, and there was even some extraction or mining of those phosphorus-enriched limestones as a fertilizer.
So, Royal, you mentioned
yeah, Ascension, there's a cave. You can look at it from the top, and they used to extract phosphorus from the cave, and from Curacao used to also be more hilly. Now it's flat.
Yeah.
Because they tear it down completely and use the phosphorus to sell it.
So there's some caves that they used to harvest phosphorus from, and then there's a small island off the coast that they have extracted a bunch of phosphorus-rich mineral from as well.
Right. Yeah, that I remember reading about. It was actually that little island nearby. Okay, and then I think at the beginning, Chris, you and I were talking about the possibility of any basalt rock quarrying, and to ask the group, is there anybody you know about any place where the rock is being mined out and broken up for use in roads or as building the.
The mountain with the two white strips.
That's not
Is that over near, closer to
Table
your place?
Mountain.
Table Mountain, okay. But what are they extracting from that?
Sand, it's almost gone.
All sand? There's nothing else that comes out of it?
Phosphate. Phosphate first. Not anymore.
So they
In the
use,
past, they put bombs.
yeah.
Every 6 o'clock, you beam.
Yeah.
But now you don't. They don't.
They used to mine it
Because it's down
for let's say,
The phosphorus?
Phosphate.
That's what?
Limestone.
Just
To
limestone?
make the road and then they make different sizes.
to make
And also sand.
Yeah, so mines like this, they usually have like dust piles or extra stuff that they can't quite have a use for. They might have rock dusts, and that might be something worth examining. If we could find out more about it, that might be something that could be something you could use on your fields potentially.
You can drive, you can go.
So,
Pick up. I went there before.
so maybe it's a field trip that mentors may take some
I
time.
went and load my pickup.
Really? Now?
Yes, I went to,
When?
how you mean when?
Because now they stop you at the gate. Don't.
I told them I'm going to buy sand. You can tackle there, of course.
Together,
Yeah.
hopefully.
You can go,
Yeah.
even rocks you can buy there. You can,
That's,
I'm going to buy that too.
Yeah. So potentially you're allowed in if you want to buy something, basically.
Just take the money for that, it's by you. And you can drive in. And then they're gonna throw the sand right on.
All right. What next, Sam?
What next would be, I have to change what I'm sharing and go to semi-arid.
Jesus.
Yeah.
This is weird. Here we go. All right. You can all see this. Oh, I can do little things. I can go like that. Wow. Clear all drawings. Huh.
So
Wow.
Sam found this paper. It's where a lot of his information came from. This is a study of Curacao and its soils. This has been uploaded into the student shared folder. There's certain parts that are more technical. There's certain parts that are less technical. We'll kind of talk through some of the parts that are more digestible, and then you can take some more time to look through it if you like.
All right. So there's a bunch of different things here that I can help you try to understand. And
A little larger, Sam. It's hard to see the text.
yeah, let's go. Let's make it bigger. Tell me when we're getting there.
It's pretty large. Maybe go full screen with it, or larger, yeah.
Yeah, full screen. All right, full screen. Here we
Yes.
are.
All right.
Now let's see how much of the text is off the, yeah. Okay, let's knock her down just a bit. That should work. And then
Yeah,
go to,
that works, I think.
how's that?
Yeah.
That's good. Yeah.
Okay. Whee! All right, follow the bouncing ball. All right, so they were trying, this guy was just trying to do a basic survey of the soils. Up to this time, there had been older surveys, but he was trying to apply modern techniques to it. And so they concluded that they got 6 homogeneous groups or soil types. The Midden Curacao, arid, you've seen these, the basalt west, basalt east, and so on. And then they got, so this is some background. So, things that you can probably easily understand. Geochemical just means what's the, what elements, what minerals are present in the soil. And you can look at the bedrock, but there can be other things too. So there could be soil forming processes and climate, topography, all of those things I was talking about. Anthropogenic, that's human influence, like fertilizers or pollutants. So the question then is about what to do. Are there environmental concerns, agricultural concerns? So they were trying to get I'm going to have to go by column. So we're starting down the left, to get good data on the contents of the soils. And then this describes some of the methods that they used for the analysis. And then what you expect for a background levels of certain elements. Some of them may be of concern, something like chromium, for example, but not as bad as some others. Okay, so what they're saying here is in 1941, this one man, Hamilton, said, you've got limestone red and limestone gray soils, volcanic soils of brown or sandy gray. Diorite is the name of the type of volcanic rock. Red or / brown serpentine schist soil. Okay, that's one that didn't come up in this paper's 6 types. But a serpentine soil is one formed from a kind of very deep earth rock that is very high in some elements, to the point where it's actually toxic to plant growth. So might want to avoid those, but you're probably not on them.
Is that not terracotta?
It's possibly because
We have a piece of, when you go into the west, there is a piece called terracotta, means red
Red
soil.
Really?
But that is not the place where you're going to plant,
So people avoid planting there already.
because you can use it. There's a lot of minerals, but it's not really for planting.
Yeah, so there is a section of the island. What was the name? Terracotta?
Terracotta.
Terracotta? Red soil.
Okay.
And most people avoid planting there in general, but it's known that the soils are rich in minerals. So.
Yeah, these soils, where these kinds of things occur, there's often potential for mining of nickel and copper and other metals, but maybe not there. So the interesting history of this is Curacao, 80 million years ago, this volcanic rock was coming out of the bottom of the sea. So this was a volcanic eruption that took place in the ocean, way down. And some of that material was of a deeper origin and has this characteristic of that makes the red soil. I've been in places with this, and you go in, it's like you cross some boundary and suddenly there's nothing growing, because very few plants can tolerate the high metal concentrations. So it's not a good place to grow. In small doses, it might be useful as a source of minerals. Okay.
Hold on a second, Sam.
Go ahead.
Cactuses.
Are there any plants you know of that do grow in this kind of soil?
Cactuses? Because
Yeah.
we have cactuses growing there.
Yeah.
Me. It just depends on the area. There's plants that do grow on these typically won't grow very well anyplace else because they are physiologically they are evolved to tolerate high metal levels, but they are not very good at growing in other places. They can grow there, but other plants will grow so much better that they lose the competition with other plants. But those normal plants will be completely unable to grow on these red serpentine soils.
Gotcha. Cool.
Right. Okay, so anyway, then there was another study. So the guy's doing what he's supposed to do as a scientist. He's reviewing the previous work. And then this other study from 1968 said there's soils on limestone, soils on diabase, which is yet another name for basalt. That's
They recognize that one.
yeah, right. And then alluvial soils and colluvial soils. So these are the erosion deposition problem. So limestone, they said about 28% of the surface area. Porous, mostly slightly saline. Reddish soils and lagoon soils of lower depositional terraces. So that would be the grayish or other limestone soil. So depositional terraces just is, what level of the limestone is that? Because there's layers of it. The volcanic cover about 38%, and the soils are not very thick. And then drainage basins drained by ruis. You guys know what that means? For Chris and I, that's like what?
Trenches. Yeah, trenches.
Trenches, okay. So the alluvial, colluvial, these are found in ruis and plains. So this is where erosion has been moving things. Moderately deep, clay loamy, okay. Some of them are vertisols. So this is an important thing. These can be the darker ones, and vertisols have the characteristic that when they're dry, they are very hard. They almost are like bricks, and they crack, and they form deep cracks. And when they get wet, when they're completely wet, then they're not bricks, but they are very dense, really hard to dig. They're clay. They feel like they're made out of nothing but clay, and they're extremely a big problem for soil tillage. But then there'd be some day when they're just right, and then you can work them. Every other day, they're like a brick, or they're this, what we call gumbo. Very hard to use. So I hope you don't have that. Okay, then they talk all about.
Yeah, yes, they do. They have it.
They have this. So there's like that, it rains and you can't do anything, and then you wait, maybe one more day, then one more day, and then you go shopping and you get back and it's bricks. And you missed your chance, right? That sounds familiar? Never mind the shopping part.
Yeah, that's about right.
Okay. So yeah, so the problem is this is like deeper soils. So darker soils, you're thinking, okay, this could be good, but it might also be in this category of vertisols. Don't know what to do about that. It's kind of it's a property of the clay in the soil. So this is what's called a montmorillonite clay, and I can't tell you why, it does what it does. But what it, at the fundamental basis is when that clay mineral absorbs water, it gets larger, it puffs up. When it dries, it shrinks. So it has the strongest shrink swell difference of almost any kind of clay. And so it forms big cracks when it dries. All right, so Cretaceous, so this is, it was moving around, yeah, you know, 60, 70 million years ago. And then here's that map which you've seen. Two large parts of the Curacao lava formation, the west and the east. Then there's a bunch of technical things about it's a submarine extrusive succession of basalts, blah, blah, blah. So that means it was an undersea eruption. Deep, and this is interesting here, deep weathering. Okay, regolith, that's what geologists refer to, that's breaking up the rocks. You know, this is, regolith is like what is on the moon, all little fragments of stones. But it's down to 15 meters, there's weathering. So this is saying that there's deep weathering on Curacao. And they say that this has to have happened when the climate was much more humid. So there was a time, I don't know when, but a long time ago, maybe thousands, hundreds of thousands of years, when it was a humid climate. And the rainfall promoted weathering way down into these lava rocks. So then they say that you can see in some road cuts strongly weathered basaltic rocks with recognizable pillow structures. So this is when you would see this. Anybody recognize that?
Pillow structures.
Yeah, it's sort of like you see these sort of rounded blobs. They're sort of all packed together, but sort of somewhat rounded, and they may be flaking off a little bit around the edges. So you just would see, instead of like a solid wall of rock, or rock with, say, like, somebody have a hard pillow at home and they're making a joke about it?
Someone sneezed and everyone felt it.
Oh, raining again, huh?
Yeah, yeah. I mean, I've seen things kind of like this on, like, Christopher when I was hiking. I saw, like, things flaking off of rocks. Things like that.
But if it's rounded flaking, that's what the pillow structure is.
Gotcha.
Oh yeah. I've seen some places where you see the weathering. You see a lot of water falls down that place, and you see a lot of round rocks playing around. And if you hit them with another rock, just like a piece of the shell breaks off.
Yeah. So that's an example of the weathering that, like,
Right.
weathered 15 meters deep. It doesn't mean that it's broken up, but it means that it's chemically changed so that it can break apart easier.
Right. So then that surface weathering, or at the surface, gives you this characteristic brownish red, sandy to pebbly soil. So that's probably what a lot of you have that are on the lava base. The next thing that happened was this knip group of stones on top of some of the lava, and then there's a bunch of other stuff in here. Pelagic means open ocean, clastic means little bits and pieces, you know, fragments of sediments, and there's a lot of differences within it. And then the midden Curacao is, let's see, that's again, this is fragments of stones eroded from someplace, some deposition from the ocean environment. And so, but it also formed basically underwater. All right, and then you've got the limestone, which they said is mostly coral debris. what got consolidated and then lithified. That just means it got turned into rock under subaerial or submarine conditions. Subaerial means out in the air, so this was on land, or submarine while it was still underwater. So this is through dissolving the carbonates and recrystallizing the carbonates. That's why I put that cave photo in there, because that was dissolved carbonates that got redeposited, recrystallized. But within the limestone body, those loose coral fragments get glued together by calcium carbonates dissolving somewhere else and then depositing and then getting it all stuck together. Okay. Now, then they said after all of that, the island was uplifted, came up out of the sea in a number of steps. And so what they say then is you can find sea-cut terraces. So this means, you know, you would have like a gigantic step shape of the land by the, as you go down from the center of the island towards the sea across the limestone. Does that sound familiar? You've seen this?
Yes, yeah, very familiar.
Very familiar. Okay. And then during that uplift, now you have opportunity for water to start eroding valleys in the stone. And then, so first through the limestone and then second through the basaltic rock core, and transported through the valley towards the sea. And then you get some narrow valleys, the narrow gorges, and widen. So then there was, after that uplift, then there was a period when the island started to go back down a little bit. So there may have been wider valleys on a bigger island, but now those wide valleys have become inland lagoons or bays, which turns out to be a good thing for the ports of the island. Okay. All right. Then this business about the phosphate deposits. Some areas of the limestone. Quaternary means the recent period of geological time, the last million or so years. Some phosphate deposits. So there's fish remains, seabird excrements, and then this gets dissolved by rainwater and precipitates or deposits in phosphate rocks. So that's the Klein Curacao. That's the island I guess you were talking about, and Table Mountain. You guys mentioned that. That's good. So you know that place really well. And then the west part, there was some explorations for copper and manganese. So at the boundary of the old lava and the next one up. So it's a really surprisingly diverse island. For a small place, it's got a lot of different kinds of rocks and a lot of history. Okay, groundwater. So they talk a little bit about groundwater. And so it's mainly, it's water within cavities and small spaces within the rocks. And there's not a lot of capacity. Weathered basalt range about 8 to 20 meters, and there's only a few percent porosity. Okay. So, and then these dams that were mentioned, the fajas, for collection of runoff, and that was these dams. And now you're saying also people are collecting sediment from those dams, which is might be a secondary use. Or maybe the people writing this didn't really understand they were mainly for catching sediment, but maybe they were for catching water.
Yeah, you catch water.
Yeah, they will catch water.
Pour the water into the ground so that the wells would have water. Then the wells behind the dam would fill up.
So it's a way to hold that water for the wells near the dam.
Right.
Well.
So for collection of runoff and to improve groundwater level, that's this last part right here. Okay. Now it goes on to a little background on soil formation. So this document is really a kind of a really good introduction to a lot of things about soils generally, but very particularly focused on your place. So you've got a good thing to look at here. We haven't got to the tough part yet, but this is the useful information. So you've got under semi-arid conditions, weathering is slow, not so intense. But there's evidence that there was an earlier period of much more strong weathering. Okay, so other basalt, so there's some red ones, and then there are some darker ones. Montmorillonite, that was that clay that makes the gumbo soil. Hematite is an iron oxide. And these soils typically form at depressions and limited leaching and weathering due to the low permeability of the Montmorillonite clay. So that's why, you know, the gumbo soil has a very low permeability. The bulk density is really high. They're tough. There's just no holes in there, and water tends to accumulate there.
Do you have worms inside that type of soil?
Would you see soil life like worms in that kind of soil?
I think I see worms.
Yeah, I have dug up earthworms in a similar kind of soil in California, and I'd tell you those were the most expensive worms I've ever dug up. In calories. I didn't have to pay anybody, but I certainly had to spend a lot of time. And you have to break each clod of soil apart by hand. You don't want to chop it. You end up with just chopped up worms. So I had to break everything.
So if you have soils like this, a couple people in here might, adding organic matter and compost is one way to help lighten it a little bit, make it so that you can work it a little easier.
Yeah, we hope. We hope it works.
Really hard. I've seen it. It's like I've seen wormholes, and you think, oh, seems like soft soil, and you dig inside there.
Yeah.
But when it's wet, you can handle it a little bit.
Right.
But when it's dry, it's like.
But don't go to the store.
Like even 15 cents.
Yeah, don't go to the store.
Right. Yeah. Even starting. The simplest way is to start covering the soil with organic matter, the biomass. That's the quickest way, or the simplest way to start modifying the soil structure. But building the compost, working the compost in, that's the next best way. Using compost teas, things like that to help the soil life restructure it. That's another way.
Okay. So onwards then, calcium carbonate and other things that are soluble. But in this semi-arid conditions, you've got a lot of evaporation, so that's the evapotranspiration. And you tend not to get a loss of minerals or loss of salts, which can be good, but it has some side effects. If you do have some salt content in the soil, then it will not go away. So sea spray is an important factor in the coastal areas at least, and maybe the whole area. When you think of it over the long term, that sea spray is depositing salt and other things from the sea on the ground. So that could be good because there's a lot of good nutrients in the sea, but it could be bad if it's going to cause salt buildup. Okay, and you can even get in some places a carbonate accumulation that can form like a rock-like layer or a dense, hard layer. I don't know that this is a problem you've encountered. Anyway, climate, so they tell you about the climate, which you know. Strong trade winds, mean annual precip about 574. And about 10% ends up as runoff. So That's good. Not all of it, you know, most of it stays on the land. Okay, so then describes the vegetation, the land use, small scale, mostly situated on the lava formation, rain dependent, what products have been traditionally grown. So you may recognize this, it sounds familiar. Drip irrigation, which has the danger of salt accumulation. All right, so even 19 years ago, the population was very much the same. All right. So now it goes into the technical part. This is their map of soil sample locations. They tried to do it in a very systematic way, but there were some areas where they were not allowed to take samples. Then they go into all of the details of how they handled the soils, and stored them and transported them to the Netherlands. And they did the soil sample preparation, geochemical analysis, and all this kind of crazy stuff about aqua regia. This is an acid that will dissolve gold. That's why it's called aqua regia. They used that to, they took a set of samples from different areas as a kind of a beginning, and then they did their broader sampling. So this is tables I've shown you before for the soil, the texture, the sand, silt, and clay, the pH, carbonate, and organic carbon. And so then they go through reviewing all of these. Different kinds of soil results that they obtained. And they identified certain types of clays, kaolinite, montmorillonite, which is the one that makes for the gumbo soil, and illite. And I don't know the differences, but illite is a non-expanding, and so that's easier to work. And then expanding montmorillonite is present in all samples with basalt, which have basalt. Okay, so they may seal and shut soils when wet and therefore severely limit leaching and weathering. All right. Kaolinite almost everywhere, and montmorillonite can break down into kaolinite. So that's good. If you wait a few more thousand years, your gumbo soils will break down better. All right. So anyway, there's this, I didn't show this on the slide earlier because I didn't think it was of any great practical value. And, you know, quartz is present. There's some quartz in the basaltic rocks and some of the other rocks deposited, and so on. Then they mentioned something about what kinds of iron is there, and then table 6, and then they do this fuzzy C-means clustering data analysis. I have no idea what that means. They try to explain it a little bit, and then they give you general composition of soils with the kinds of elements and so on. And then further on the analysis techniques, and then they did the result of that analysis was the 6 clusters. The soil samples formed 6 identifiable clusters, and that's where they came up with this thing where they say basalt east, basalt west, AC, AI, you know, those kinds of things, Midden Curacao, those 6 general categories. That's how they got those. They use all of the different data that they got for each soil sample, and then they do this thing which finds the ones that are most similar and piles them together. Okay, so it's a way of detecting some things that are similar. Okay, sandy limestone soil type. So this is the details of the descriptions of each of the soil types. Here's the data I showed you that, but so like here they describe in more detail the sandy limestone type and the clay contents and or water holding, all of these things. So this has some practical value. If you're on that, you would want to read this. Midden Curacao. But also I would have to say, because we expect you to become the leaders of the next, generation to spread the knowledge, here's a source of information. Somebody comes to you say, I'm going to do this. And you say, you appear to be on the sandy limestone soil type. Maybe you should consider moving another place or something like that, depending on these kinds of results. But it should be fairly clear. The Midden Curacao type, and then they go on into the arid calcareous type, all of the details of that, and they compare to some of the others. The basalt west gives that a detailed description there. And then the agriculture influenced, so anthropogenical agriculture soil type with fertilizer and irrigation, high contents of potassium, calcium, magnesium, sodium, that would be the salt problem, and SR, which I think is strontium. And then other elements are there. Addition of phosphorus to calcareous soils may lead to a quick revert of phosphorus into insoluble forms. So that is why you don't want to elevate the pH too much. Then they go into the basalt east, and then the geochemical mapping. So they take all of their different soil sampling points, and then they made these maps, which I didn't provide in the slides because I thought it's easier to digest this information in those summaries that we just saw on the previous pages. But if you want to know where the copper is, here you go, right there, there, and there. And aluminum and barium and iron, nickel, calcium, chromium, phosphorus. So here's your high phosphorus zones. Maybe those are some agriculturally influenced soils or the Midden Curacao or something. So this is just some of the elements that they did. And then they discuss the distribution, and then the what they call the background level. So they're concerned about environmental contamination and environmental levels of the metals and other components of the soils in relation to the Dutch references for what's safe and what's not safe. They say may be contaminated if compounds are present at higher concentrations than expected from baseline. So, all right. Anyway, that then into the sort of the general results or the discussion. They said you need to consider all the specific characteristics and processes that affect the contents of the soil. So that's what they tried to do in this project. And I won't go through this. So they do say where you find the SL, sandy limestone, limestone formation, and knip, and MC on the Midden Curacao. And then there are some salineous saline soils from middle limestone terrace and so on. So they give a little bit more information about where these things are. Arid calcareous, lower limestone terraces only, and so on. So again, you can get practical information from there, from these paragraphs. Basalt west, agriculture influenced, agricultural soils and gardens with basalt formation origin. So that means that the original, predominantly the agriculture was on the basalt origins soils. And you get, they had some high levels of zinc in one. They say it's probably a single source trace element from some kind of pollution. And then they talk about the basalt west, basalt east, and so forth. And again, so this just walks you through values of the soils, some of the, you know, when a scientist writes up the results, you often want to say, well, here's some things that we did that might have affected the outcomes, or here's some things we could do differently if we were going to go at it again. And so they do that. And then they have some conclusions. And so this, the 6 geochemical soil types, and based on element content, soil processes, and that's how they made that decision. So this is what I pulled this out and summarized it on the slides that I showed you. And then you have a few things about the, just sort of in conclusion, an important threat for soil is the impact of industrial fertilization. So, and nitrate pollution on agricultural sites from the use of chemical fertilizers has caused some groundwater issues. So this emphasizes that you should probably not use those kinds of chemicals on soils because they will enter the groundwater in addition to reducing soil quality.
Some questions.
Yeah, I don't see that they took in consideration, maybe because it's done before the shell was here.
This report's from what, 1974?
This one we're looking at,
Yeah.
this one's 1990, 99 to 2000.
99, 2000. Okay.
99.
So there was the Shell company was here, and they had a heavy impact on the environment, water, oil, everything. So there's a question of how that might have impacted, or how this report doesn't actually talk about that at all.
Right. Yeah. Yeah, that's, yeah, I have to say it's very much missing.
Our company paid for the test.
Yeah, maybe the oil company paid for the whole thing.
Maybe. Well, maybe they wanted to live to get to the end of the project.
I mean, they could have limited their scope simply to soil testing and limited their, I mean, the comments they make about, you know, fertilizers and groundwater are one paragraph out of the whole thing. And even that's very concise and quick. So
Right. Now,
the limit there.
so where is the Shell area, like here?
Yeah, it's in there.
Yeah, notice there are no soil samples taken there.
It's actually here. It's actually, it doesn't see it, but it's actually.
I mean, it goes
And
pretty much exactly. It's
This
about
area.
it's about where you're pointing. It kind of it's around that inlet there, that inland area.
Yeah,
And then there's some holding facilities off to the west a little bit more. Kinda
like
where
here.
Yeah, and up on there a little bit.
Okay.
But
Yeah.
there's a glaring hole right where a lot of the refinery is, which is interesting.
Yeah, and they also didn't get out here, but maybe that's just too
There's
hard.
there's some Dutch brothers, I think, wasn't it? That en masse, they don't let anybody onto their land. Yeah, it was interesting on the specific minerals that east section is completely blank. Yeah, they just don't let people out there.
No, they don't. They mentioned there were some areas that they were not able to have any access. They could not go on for sampling. And here there's also a big hole.
Those are hills.
That's like Christopher. That's the mountain.
That's the mountain. Okay, so maybe it wasn't useful to go there, but I think they probably could have taken some samples if they had tried. Wanted to, but yeah.
It's a national park. Maybe that would have had.
Yeah, that may have been a problem.
Interesting.
Okay. Well, any other questions about this? You know, you can all get a copy of this from Chris or wherever it's stashed. Yeah, that's that property right here, huh?
Yeah,
Yes.
that's it.
This is
These Dutch guys, they didn't like anybody to be there.
I think they still live in the 1700s or something.
Yeah, that's a pretty sharp natural boundary, isn't it? A straight line and then another straight line.
Yeah. Weird.
You're allowed to bike there. You're allowed
Yeah.
to bike.
Okay. So some recreation's allowed there.
Northern parts, eh?
I bike there.
Maybe that's recent.
Well, is that the end of the material for today, Sam?
That would be the end. Yeah.
Okay. If there's no further questions for the day,
I wanted to ask something. Go back to the maps, but
which maps?
the ones with the black ones. Yeah.
You go to the black and white maps, the mineral, the specific elements.
Yeah.
If you go up a little way, you see the copper. Let me see.
Copper.
Yes.
How it's concentrated here and here and here, and that's like near, I think, where water used to flow towards the ocean. Does that have something to do with the?
Could water movement influence the distribution of copper on the island?
I guess it could. I'm not really sure how that would happen. You've got it would be originating from the lava or the boundary, the contact layer between the old lava formation and the Knip in the east part anyway. In the west part, but in the east, I don't know. That would mainly be the result of the qualities of the rock, and of course, yeah, you could have sediment coming down and in those areas. See, I don't know the topography.
Like higher.
No, those are lower parts. These parts are lower parts.
Low parts.
Yeah,
Low parts here.
This is hilly.
Okay.
This is hilly, and this side is also hilly. So it's like this is like a depression here. Here also, there also.
Interesting. Well, look at the iron. You go to the iron. The iron follows a similar pattern as the copper.
Definitely, yeah.
So that could be something. What about the other ones? Nickel a little bit.
Yeah, not so much. Calcium's almost opposite. I mean, there's kind of no trend here, but that low area, that area. P. Chromium also kind of like the copper in some spots, but not every.
Yeah, the P is like the shell. You see, it's just close to the shell.
Yeah.
Probably that is something from the shell.
Yeah, maybe.
That's a lot of midden Curacao, and
Well, you can see Table Mountain for sure.
Yeah, this is Table Mountain.
Yeah, that'd be Table Mountain. Yeah.
here.
Tafelberg, Dakinanta, Gulumbay, Juliana Dorp, Syria Manica. Syria Manica.
That's where the red earth is it?
Yeah, red earth is here.
Okay.
But that is the Mid-Curacao formation.
Yeah, this is
Yeah.
That is Mid-Curacao formation.
But you could probably compare that to the soil map and start to draw some regions of like this soil has this kind of thing. So this is incredibly specific info for you guys. I mean, this is tailor-made for you specifically. So I just encourage you to look into this, learn more about your area. This is like a baseline of like, all right, I can kind of start learning about my soils here. And then based on what you can gather from these maps, from this research, you could go out to the internet and start searching for this soil type or these elements, or what does it mean if you have a lot of this or not much of that. You know, this is a great jump off point of this is your island, and you can find where you're at and go from there.
Yeah, and I would say as a, you know, as you could also, at some point, if the time allows, maybe, you know, later in the season when things are more kind of on autopilot as far as growing is concerned, try to organize a little field trip and try to hit some of these spots and look at the different soils. As you really, to look, you know, when you're looking at soils as a newcomer to the process, often you don't even notice what's different about them. And then, but now you've got to start at this, and you know, you all have experience with your soils in your areas and places you've visited. But you know, go out and take a look around, try to find these different main soil types, or just take a dig here on the limestone and there on the lava formations, and the Midden Curacao areas, limestone terraces, all that kind of stuff. You can start to see, a lot of these things directly.
Got another question here, Sam.
Right.
Yes,
When you go down to the map for phosphorus.
Can you go to the phosphorus map, please? Yep.
Yeah.
There you see those areas are actually very close to the salines we have on the island. Is it because of the pH that the phosphorus is higher in that area?
Salines?
Concentration of phosphorus.
The salt.
Salinius.
Oh, yeah. The comment that those are where a lot of the seleniums are. Could that potentially be an accumulation point?
Yeah, maybe so.
Yeah.
Yeah.
Yes,
See the salt pond,
salt pond.
Yeah.
Yeah.
So wait, I mean, this kind of hints at water leaching. I mean, this is something that we have an issue with back home, you know, like minerals being caught up in water and carried away.
Right. Getting
So
lost.
yeah, so that could be an example of an accumulation point of phosphorus.
All righty.
Cool.
Okay.
All right. So good class. Thank you, Sam.
Welcome. It was fun.
I'll talk to you on Monday.
On the globe, ladies, on the globe.